Okay, I had another problem. F of x equals x minus 1 to the 4/5. We want to determine when f was increasing, decreasing, and find any relative extrema. So we start by first finding the derivative. You can do that by the chain rule. We get 4/5 x minus 1 to the negative 1/5. And then just getting rid of the negative exponents, we get 4 over 5 times x minus 1 to the 1/5, or alternatively writing it as I did, the 5th root of x minus 1. We then want to figure out when that derivative is 0, when it's undefined. We figure out, well, when is it 0? Well, it turns out it's fraction. Anytime a fraction can be 0, then the numerator is 0. Doesn't happen. When is it undefined? Well, it would be undefined at points where the denominator is 0, and that would occur at x equals 1. Okay. This is a 5th root, so it is defined on both sides of x equals 1. So now we found the only value of interest, which is 1. We will then take that value and plot it on a number line. And set the derivative in these regions. Is it bigger than 0? Or bigger than 1? Or big smaller than 1? And then we take those values and evaluate the derivative at 0. Well, if we plug in 0 into this derivative, x minus 1, well, 0 minus 1 would be negative 1. 5th root of negative 1 is negative 1. 4/5 times negative 1 would be negative 4/5. So we find out that it's negative in this region. And likewise, we plug in 2, and x minus 1. 2 minus 1 would be 1. 5th root of 1 is 1. 1 times 4/5 is positive 4/5. So it turns out that the derivative is positive there. Now we know when the derivative is negative. We know when it's negative. Well, when it's negative, the function is decreasing. So we know it's decreasing on the interval negative infinity to 1. And we know it's increasing on the interval 1 to infinity. Now there's one last question, and that is, do we have any relative maxes or mins? Well, relative maxes and mins would occur at points where the derivative switches sign, provided those points are actually points on the original graph. Well, a quick check of the original function here, x minus 1 to the 4/5, tells us, yeah, hey, it is defined there. X minus 1 to the 4/5, it is defined there at 4/5. I'm sorry, x equals 1. 1 minus 1 is 0. 0 to the 4/5 would be 0. So this is a value of interest. Even though the derivative's undefined there, the original function's not. So this is a value of interest, even though the derivative's undefined, the original function is not. Well, it's decreasing, it's going down, and then it's going up. Okay, that means that we have a relative min there. So we can say that we have a relative min when x is 0, and of course f of 0 would be 0. And we can say pretty confidently, since that's the only one, that we have no relative max. Yeah. And now we've answered all the questions we wanted to find out.